Good morning. Today's lesson is an application and an extension of what we learned yesterday about finding zeros and multiplicity. Our goals for this lesson are to identify important characteristics of polynomials and to graph polynomials to the best of our ability using some of the key characteristics of the graph. The only difference from yesterday is now we have these functions in standard form, which means that we have to factor them and then use the factored form to find some of the different pieces that we need. So let's start off with this first function, f of x equals x squared minus 25. This is a difference of two squares, so it's going to factor into x minus 5 times x plus 5. If you recall standard form, the c value is our y-intercept, which is going to be right here. This is our c value. So the y-intercept is going to be 0, negative 25. Our degree is taken right from the polynomial itself, which is x squared. So it's a degree of 2. And so based on the degree and the fact that we have a positive a value, we have an up end behavior for this graph. Finally, the two zeros that we have for this function are 5 and negative 5. So 5 comma 0 and negative 5 comma 0. And both of these have a multiplicity of 1 because they have an imaginary 1 exponent right here on the binomial. So if we continue on, we have a 1 for the multiplicity in both, and this means that we cross the x-axis in both scenarios. If we go over to the graph, we want to mark our y-intercept down here at negative 25, and we are going to draw the graph through the two intercepts, which are going to be at negative 5 and 5, up and up behavior. And so we have a quadratic with a degree of 2 that intercepts the x-axis at negative 5, down to the negative 25 intercept, and up through 5 to finish it off. There's our first example. Our second example, we need to factor out a GCF, and because we have a negative first term, I'm going to take the negative 1 out with it. So here we go. We're going to take out a negative x times x squared minus x minus 6. If we continue on, I'm thinking in my head, what multiplies to negative 6 but adds to negative 1? This is going to be negative 3 and 2 for both of these. So we end up with negative x times x minus 3 and x plus 2. There's our factored form. You'll notice we have three factors here. We have this negative x factor, we have the x minus 3, and then the x plus 2. Having three factors means that our degree is 3, which matches the highest exponent in the standard form equation we started with. Our y-intercept this time we have to calculate, and I believe it's going to be 0. If we plug in 0 here for this function, we're going to get negative 0 cubed plus 0 squared plus 6 times 0, which all equals 0. So here's our intercept at 0, 0. Our end behavior this time is going to be an odd negative behavior, which is acting like a negative linear function. So we are looking at an up, down end behavior. Up, down end behavior. If we go to the zeros, we have 3 of them. We have negative x equals 0, so that's going to be 0, 0 comma 0. We have x minus 3, which creates a 0 of 3. And then we have x plus 2, which creates a 0 of negative 2. If we plug these in, they all have a multiplicity of 1, which means that they cross the x-axis each time. So no bouncing here for this problem. We're just going to cross all 3 times. So 0, 0, 3, 0, and negative 2, up and down for our end behavior. So our function will look something like this. snake through 0, 0, and down through 3, 0. And there's our second function. The third example, if you flip the page, is a little bit more tricky. We're going to add another x to this. So this becomes a degree of 4. Our end behavior with a positive a value is going to be up, up again. And our y-intercept is also going to be 0, 0 based on the fact that we have all x's in every term. So 0 going for every x will make it 0. Let's find our zeros by factoring. So we have an x squared GCF, which creates x squared inside the parentheses plus 3x minus 10. Again, we're thinking factors of negative 10 that add to 3. So x squared times x plus 5x minus 2. These create zeros at 0, 0, negative 5, 0, and positive 2, 0. This time, though, our multiplicities change slightly. The x plus 5 and the x minus 2 are both a multiplicity of 1, which creates a cross over those x-intercepts, but the x squared has a square exponent on it, making it a multiplicity of 2. This creates the bounce on 0. So as we go to the graph, we put our intercepts at 0, at positive 2, and at negative 5. And now we can start to look at what we're doing. We have an up, up behavior. So I'm going to pass through negative 5. I'm going to bounce at 0 and go back through 2. So start up here, go through negative 5. We're going to bounce at 0 and go back up through 2. And that's going to be our example there. Last but not least, we have a little bit of an application here. And this problem is going to use volume instead of area like we used back in solving quadratics. So we have a slightly more complicated function here, which is really just length times width times height, if you think about volume. Each dimension is given in the picture as x, 5 minus x, and x plus 2. So if I start to plug this information in, we end up with 5 minus x times x plus 2 times x. This function is going to be, you could multiply this out to get standard form, but it's really unnecessary because what we're looking for is the maximum volume. And so what you want to do here is go to Desmos graphing calculator and find the local max that gives the highest value. This will give us the answer to this problem. Again, maximizing the volume is going to be wherever that local maximum is, or that relative maximum on the graph. You'll notice this is going to be a cubic function, so it's going to look something like this on the grid. So if you go ahead and look at that function, you should be able to find that maximum right here. Round to the nearest 10th. Don't forget to find your answer. And you can pause the video here for a moment to go to Desmos and try that out. Now that you're back on the video, the final answer, just to check your answer for this, is about 3.1, 30.0 if you're rounding to the nearest 10th. 30.0 is going to be the max volume for this function. That's it.